Welcome to the Ratio Christi at UNCW podcast. We are here to cultivate thoughtful Christianity on the college campus, equipping students both to share the gospel and present evidence for the gospel. To learn more about Ratio Christi, come join us at our Monday night meetings. You can follow us on social media at Ratio Christi UNCW. Our speakers often use visual aids, so check us out on YouTube if you would like to follow along with those. Thank you for joining us today. If you like this content, give us a follow on whatever podcast app you prefer. And without further ado, let's dive into this week's topic.
Oh yeah, very good. All right. Okay, great. All right, well, thank you. That was a good introduction. So, yeah, I appreciate the opportunity to be here. So, as Tom said, I've been sort of indirectly affiliated with Ratio Christi for quite a number of years. And we've had a number of times where I've been able to speak or talk to students, which is great. It's great to engage with students at the university. And UNCW's got a great program here and a great club with Ratio Christi. So tonight we're going to talk a little bit about an argument that's probably not what most people would consider a mainstream argument for God's existence. It's a little abstract, I guess, maybe is the best way to say it, but maybe that makes sense being the topic of mathematics. This is actually something I've formulated and put together. In the time since I gave this 5 years ago now, which is still hard to believe, there have actually been several other folks that have put together, I'll say, similar kind of arguments, not exactly the same. But it's interesting to see that a lot of folks are kind of coming around to this argument that maybe hasn't really been looked at very much. So we're gonna talk about the argument from mathematics. So important disclaimer, so just to get this out front right away. So this will not provide any evidence or arguments for the Christian understanding of God. So this is just an argument for basic theism. So from this, you could just as reasonably conclude the existence of some other deity or some other God, monotheistic God. So this is not something you would necessarily use as a convincing argument if you were trying to really convince someone of the truthfulness of the Christian worldview, for example. And there are lots of other evidences for that, the historicity of the Bible and the reliability of Scripture. That's not this. This is just going to make an argument for God's existence, God being a singular being of a single substance, one entity, one being. And so it could just easily be used by, let's say, a Muslim scholar or a Jewish scholar or some other monotheistic worldview. Now, at the end, you'll see that it is particular to monotheism, not polytheism. And there are some attributes that we'll talk about why that is. So, but it is unique to monotheism, okay? So kind of keep that in mind. So just setting the stage so you're not disappointed at the end when you say, hey, this doesn't show anything about Jesus. Yes, you're right, it doesn't. It does not. So this would not be an argument you would use to try to convince someone of, let's say, the deity of Christ, for example. But there are many other arguments that you could use, just not this one, okay? So this one's a good one if you want to talk to people who are highly skeptical about the existence of just God in general or the existence of any deity or God. I think this actually could be kind of useful or interesting to present, to talk to them about. So, okay, any questions on that? Just want to make sure not getting out and ahead of my skis here. I don't want anybody to be overly disappointed. So this looks a whole lot better in a dark classroom, but I did this one time. I said, okay, we're going to have the argument from mathematics. And so I put this up and I said, okay, so we're just going to start from Euler's equation. Now, this is mostly review for everybody, so I'm going to kind of move through this quickly. And I start going through the equations, and then I turn around and I see the looks on students' faces like, so we are not going to be solving any equations of mathematics at all for this class. Yes, you're happy, I can tell. So we're not going to be using any mathematical equations at all. In fact, if this is what describes your view of mathematics, and it does for some people, you will be perfectly fine in this talk. I promise you, you won't run out of here with your head, on fire, with your hair on fire, yelling and screaming. This is not going to be a class or a talk where we solve equations. We're going to use math in a slightly different way in the definitions that we're going to use in these arguments. And so what I wanted to do was kind of lay out the game plan, and then we'll define our terms, because that's always important whenever you're making an argument or having discussions. So here's the game plan for tonight. We're going to use philosophical reasoning, logical reasoning, and of course math being wholly logical and governed by the laws of logic. Math would apply here, okay? Well, we're going to use two types of argumentation. We're going to argue it deductively. That's like the first half of my argument. And the second half is going to be an inductive argument. So, and I'm guessing, I know in the past we've had classes where we've done a little bit of discussion on deductive, inductive. Does everybody kind of know what I mean when I say that? I'm not sure everybody has taken a class in logic or philosophy, but essentially the deductive argument structure, I'm going to be arguing from general to specific, or sometimes referred to as from cause to effect. So we're going to start with a deductive argument for God's existence. And then I'm going to give you the evidence, and we're going to talk about the assumptions and the premises, and if you have any questions, we can dialogue. And then I'm going to pivot near about the halfway point. I'm going to pivot to an inductive argument. Different argument, different evidence, same conclusion, but different way of reaching the conclusion. And so inductive reasons from specific to general, from effect to cause, but yet both are valid forms of logical inference. And so we're gonna actually use both here, which I think is kind of interesting. So I present my evidence, and I try to support my premises that I'm gonna give you, and then you decide, hey, are these premises valid? Are the arguments convincing? Are they not convincing? Not so sure about that premise. This premise doesn't look too strong, doesn't logically follow. So again, I'm going to try to give you the arguments and the evidence and the lines of reasoning, and then we can talk about what you think of it. We can discuss it, okay? So that's the game plan for tonight. Any questions on that? How's my volume? Is it looking okay? Okay, I just want to make sure I have a tendency to get louder the more I talk. So we're going to start off with the basic question for this argument. What is math? That's not a rhetorical question. What is math? If somebody came up to you with a person on the street interview, Maddie with her microphone, and said, what is math? What would you say? What do you think math is? Or how would you define math? Whoop, I'm going to put this over here so I don't fall over trying to get to it.
I would say like solving problems with numbers.
Okay, all right. So numbers, yeah, numbers. Certainly math involves numbers. What else? Maybe think more generally, in more general terms. Yeah.
I mean, it's like truth. It's like rules that are no matter what, they're true.
Yeah. Okay. So math does involve rules. There's order and structure to math. You ever seen those problems? I don't know. Maybe you've seen these. They're like on the internet. It's like 2 plus 3 divided by 7, times 6, squared or something, right? And they say, what's the answer, right? You try to figure out what the answer is. Well, there is a format. There's a way to solve this, and it's governed by rules of mathematics. You don't do addition first just because it happens to be first in the equation, right? You start with parentheses. You do exponents, right? I don't even know if they teach this anymore. Please excuse my dear Aunt Sally, right? Start with parentheses, that's first, that's order of operations. You go to exponents, so you would do this first, right? You do this first. Then you go to multiplication, division, addition, subtraction. Rules, I like that word. Rules, order, structure. You can't just do whatever you want here. There has to be order and rules. Otherwise, what happens if there's no order and rules? Yeah, everybody gets a different answer. Everybody gets a different answer. And that doesn't work for mathematics. We can't have everybody getting a different answer, right? That's just not a good way for math to operate, and it's not true. I think you even said rules and truth. I love the way, that's a great definition, yeah.
Do math help us to predict things in the universe?
Well, I would say that the rules of math are what they are. But I would say the nature of math can help us predict what's in the universe. But the nature of math is governed by the order and the rules. So yeah, maybe indirectly, yeah. Okay, any other thoughts on math? I don't want to spend too much time on it, but I really do like your definition of rules and order and truth. That's a great way to start this. Okay, I'm going to say, so this actually comes from Webster's dictionary, and I'm going to look at a couple of things in here that I think are kind of interesting. So when I look at this, I see words like systematic, treatment, kind of implying rules, order, relationships, figures, the relationship between figures and forms, and relationship between quantities expressed symbolically. Somebody said symbolic or symbols. So we've got symbolism, we have relationships between forms and figures, we have a systematic way of doing stuff. We can't just like make it up on the fly, right? We have to do things in an order. And so I would say when you look at math, it clearly is a relationship between figures and forms. In other words, magnitude or number and an object itself. So if I were to say, how long is this clicker? You would get a ruler and you'd say, I don't know, like 4 inches, right? There's a relationship between the form of this thing, what it is, and its dimension, and then how it compares to a standard, a ruler. And we say, yeah, 4 inches. And we would say, yeah, that's like, I don't know, maybe 12 inches, right? So there's a form and a way of doing this that's ordered and structured. And you said this, expresses it symbolically. I think that's a very important thing. So in other words, it's taking concrete physical reality and expressing it with symbols or numbers, which are not physical. They represent the physical. I would also say, and again, great definition, procedures, operations, properties, right? You can't just do the math any way you want. There has to be an order to it. And I would say that if I could just sort of generalize this, I would say that it's physical properties. So that could be height, width, length, mass, temperature, pressure, flow, you name it, stress, strain, and pick any physical property you can think of and represent it by abstract forms or symbols. Any physical property you can think of, how much something weighs, what its temperature is, its mass, if it's moving, what its velocity is, what its acceleration might be. Any physical property that's represented by abstract forms or symbols. That's probably one of the better ways to think about mathematics, right? Because these symbols and these forms, right, themselves are not physical, but they represent something that's physical, right? So when we say this is 12 inches long, the 12 inches isn't physical. It's a concept in our mind of length, but it corresponds to the physical. And so we say, yeah, 12 inches. We recognize that there's a relationship between the physical and the abstract, how our mind perceives the physical. And so we would say that's a good working definition for mathematics. And that's the definition I'm going to try to use tonight. Again, there are other ways of defining it, but I think this is a reasonably good starting point. Any questions about this right here or these definitions? Does it kind of make sense, what I'm saying? Is it kind of, again, so we're not going to be solving any equations. We're going to be doing this in a much more abstract, philosophical way. Okay, so here's my deductive argument. So again, I said first one's deductive, second one's inductive. Let's do the deductive first. It's actually a very simple deductive argument. I would propose that if God does not exist, then the astounding correlation between abstract mathematics and the physical world, physical reality, is nothing more than a happy coincidence. I would further propose that the astounding correlation between abstract mathematics and physical reality is not a happy coincidence. I would therefore then conclude God exists. So the question is there an astounding correlation between abstract mathematics and the physical world? Because if there is, then we have to either affirm that it's just an unbelievably happy coincidence, or we have to consider that maybe there's some order and structure here that's not a coincidence, that maybe there's something else behind the correlation between those two. So that's what we're going to look at, the correlation between those two. So the question then, my job is to kind of prove to you, or at least try to defend the fact that I think there is an astonishing correlation between abstract mathematics and physical reality. And I hope to be able to prove that to you. Yeah, you have a question? Yeah.
Would you say that it's an astonishing coincidence that there's a lot of these things that match up really well with the word like water bottle?
Not necessarily.
Okay.
I mean, again, we could all agree to call this, a banana if we want. I mean, I don't know if it's the word that we're looking at, but I would say that if there is an astounding correlation, I think it would imply that there was some intelligence behind what made these. These things didn't just randomly appear in nature out of nowhere. And they do seem to be similar, and there is an intelligence behind what made this. Yeah, question in the back? I saw a hand.
Well,
Yeah, that's dichotomous, right? So it's either God or no God.
In this argument, yes.
Is there alternatives?
Correct.
Like aliens?
Yeah, right. And so we would say certainly there could be a third option for sure. So God might not be the best explanation there. But then, of course, we'd have to go look for the evidence for aliens. Right? We'd have to see, okay, well, maybe, you know what, maybe there is good evidence for aliens who made this astounding correlation between physical reality and mathematics. So certainly that's possible.
So does that get that statement correct then? Or is it just saying, therefore, God could exist?
Well, in this argument, it would be God exists since it's a deductive argument, right? So again, if God does not exist, then the astounding correlation is a happy coincidence. I would argue the astounding correlation is not a happy coincidence, therefore God is the explanation. Now, we could put aliens here. We could say if aliens do not exist, then the astounding correlation is a happy coincidence. Oh, the astounding correlation is not a happy coincidence, therefore aliens exist. But then we'd have to go look for evidence for aliens, right? We'd have to go see if aliens are the best explanation, right? So I'm going to restrict my argument to God existing. But yeah, certainly there could be other explanations for sure. But in this case, the way we're going to formulate this deductively, we're going to look at the existence of God. Good questions, by the way. Okay, so is there an astounding correlation between math and physical reality? That's the question. Because if there is, it's hard to convince yourself that it's just a happy coincidence. If there was some small correlation between abstract math and physical reality that appeared every now and then, but not very often, maybe you could dismiss it as just a happy coincidence. Like, oop, I won the lottery. Oh, it's just a happy coincidence. But is that really the case with abstract objects and mathematics, abstract and physical reality? Well, let's take a look. So how does math work? Okay. So let's think about this for a minute. I'm going to give you, I think, a simple example. You're a civil engineer and you want to design a bridge. I'm not a civil engineer, but if I were, this is probably how I would do it. I would say, okay, I want to design a bridge. It's got to go from this point to this point. It has to be able to hold a certain amount of weight. It has to be able to withstand a certain amount of stress, strain. It's got to have a structure that's going to be able to withstand wind and maybe seismic events, depending on where it's built. You would take all of that into account, and then you would formulate a concept, an abstract concept in your mind of what this bridge needs to look like and what it needs to do. Right? Before you ever do anything, it's in your mind. Okay, it's got to be this long, got to be this high. It has to hold this much weight, so we need a certain number of these tension lines, right? And you come up with a concept, and again, this is all in your mind, right? Nothing physical yet, right? Maybe you put it on a drawing like this, okay, but again, It still represents this abstract physical concept. Then you get a design you think works. You have your buddy verify all your calculations are correct before you convince somebody to spend millions of dollars on a bridge. And then you start building a bridge. And this abstract idea that was conceptual in your mind now becomes a physical, concrete, and when I say concrete, I don't mean necessarily cement, a physical entity in reality. It becomes steel and metal and wires and cables. It becomes a real physical thing. So it goes from this abstract to this physical. It goes from this conceptual to this concrete, this actual real thing that allows cars to cross over a river. That would be, I think, the way math works. And this is what scientists and engineers do all the time. They formulate something mathematically, they do the calculations, they make sure everything looks good, and then they convert that to something that's physical. This would work with a car, it would work with a house, it would work with anything, right? It's an abstract idea, conceptual idea that becomes something physical. Now, clearly, this thing, this bridge right here, is man-made, human-made. So a human came up with this, and a human said, okay, we want it to look like this, with these details, these specifics, and then a bunch of other humans who know how to build things built this, based on this abstract idea that was in the engineer's mind. And we don't see things like this popping into existence in the natural world without some human intervention. It clearly seems like this is an intentionally designed structure with forethought and needing a mind and needing an intellect, because it was conceived in the mind and then it became physical reality. So that's how we see things in the world that we as humans design, we as intelligent agents would design. So the question is, do we see this in things that are not human-made? Do we see this same correlation in stuff that exists in nature? Does math apply to stuff that humans had nothing to do with? Because I think we can agree, humans, maybe most of us can agree, are generally intelligent agents. I guess depending on the human you're talking to. But we're generally intelligent agents. But does math apply to something like this that, as far as we know, had no human intervention in creating it? That's a wave at a beach. Well, as a matter of fact, mathematics predicts this perfectly. The wave equation predicts the shape, the height, the depth, when the wave will curve over and collapse based on how deep the water is, how shallow the water is, the sand below the wave. The wave equation predicts something that appears in nature with astonishing precision. Just as much precision as the bridge matches the abstract idea of the civil engineer who put it on paper, who designed it that way. Now we see something in nature that's not made by humans, but yet math predicts the behavior of this natural structure. Still skeptical. How about planets? I mean, I think I can convince you none of these were man-made. None of these were made by humans. But yet, the gravitational laws and the laws of planetary motion predict the position and location and speed of gigantic planets and orbiting, in our case, this is our solar system, orbiting the sun, but it also applies to galaxies and solar systems outside of our galaxy. The laws of planetary motion can predict physical objects that, as far as we know, were never made by a human or a human intelligent agent. And yet they can predict them with astonishing accuracy. What else? Let's go really small now. What about an atom? That's a hydrogen atom, in case you're wondering. There's kind of, it's like the proton there, and then this orbital blur is the electron cloud. Does math predict this? What do you think? Yeah, it does. It absolutely predicts this. So from the largest things that we can conceive of, solar systems, galaxies, to the smallest things that we can conceive of, atoms, and even subatomic particles, math seems to predict the behavior of all of these things. At every level of nature, math seems to be able to predict the behavior of all of this. There was a guy named Peter Higgs in 1964, as most mathematical physicists will do, spent his entire career solving field theory equations to try to predict the particle that was supposedly at the inception of the universe when the universe began. Now, this was in the 1960s. Remember, in the 1960s, there started to become a lot of evidence that the universe was not eternal and not self-existent, which had been previously thought to be the case. There started to become more and more evidence that the universe actually came into existence. And so Dr. Higgs said, you know, if that's true, then I ought to be able to mathematically predict what that particle was at the inception of the universe. It actually has a name. It's called the Higgs boson. Now, this is in the 1960s. And so, as all good PhD theoretical physicists do, he started deriving all sorts of field theory equations for the existence of this never before seen particle that no one knew existed. He couldn't prove it existed. It couldn't be measured. But yet the math indicated that it should be there. We should be able to spot or detect this particle. Fast forward to 2012, and a group of physicists at the CERN labs detected at the Higgs boson at the Hadron Collider, precisely where Higgs's mathematics predicted it would be. In fact, they knew where to look for it because they went to his field theory equations and they said, okay, if his equations are correct, it should be right here. And they did the tests and they found it. It was right where the math said it should be. Some, I don't know, 60 years later, 50 years later, the scientific experimentation and the scientific equipment actually got good enough to confirm what math had predicted a half a century earlier. But nobody could verify it because nobody had the equipment to check it or verify it. Coincidence? Is all of this just one gigantic coincidence? Pluto. So I tell a joke about this. I'm old enough that when I was a kid, Pluto was a planet. That's how old I am. Pluto. Does anybody know the story of how Pluto was discovered? I'm not going to call it a planet because I know astronomers get upset when you call it a planet. Well, let's retrace the history. In 1840, a couple of French astronomers said, hey, we're noticing that something weird is going on with the orbit of Neptune. Like, they were applying Newtonian physics. And they said, yep, we can predict Mercury, we can predict Venus, Mars, Saturn, we can predict all of them. But something's not right with Neptune because it's not exactly, it doesn't exactly match what Newtonian physics and Kepler's laws of motion would say. And they're like, what is going on here? How come it's not quite right? Something doesn't seem quite right. They call them perturbations in Neptune's orbit. So they began to speculate, hey, maybe there's this other planet out there somewhere that we don't really see that's causing these slight perturbations to Neptune's orbit. So they start looking. They got the Lowell Observatory. They're starting to look into deep space. Now remember, we're in the 1800s here, right? So it's still, equipment is still relatively crude. They continue to search. Astronomers in 1915 capture what they think is this very faint image of something, but they're not quite sure what it is. They're still investigating. They're still looking. They keep searching. 1929, still looking. But lo and behold, in 1930, they discovered Pluto, right where the math said it should be. And it perfectly predicted where Pluto's location was and the impact on Neptune's orbits. And I'm not talking like close, I'm talking dead on the money math to five digits after the decimal place. precision that is nothing short of astonishing. Coincidence? Einstein, probably my favorite story of all, just because I'm a nuclear kind of person. For centuries, people thought the universe had no beginning and no end. It was eternal, based largely in part of Aristotle's view that matter was eternal. But long about the start of the 20th century, scientists began to question this. And Einstein actually applied his general theory of relativity to the existence of the cosmos, solved a number of field theory equations, which were based on assumptions, that the universe was a closed spatial geometry, because everybody knows the universe, is infinite and has no beginning and has no end. And when he solved his math, he concluded that his math was telling him the universe was not past eternal, but had a beginning at some point in the distant past. So convinced was Einstein that his math was wrong, that he introduced what came to be known as the cosmological fudge factor to try to make the math work, because he just knew, everybody knows the universe is eternal. I must have done something wrong with the math. That's what it was. This is 1916. And over the next decade, discovery after discovery start to come in. Eddington's measurements of solar eclipse, Friedman's reformulation of Einstein's field theory equations, George Lemaitre's work, all started to conclude that the universe actually is finite. It's not infinite, it's not past eternal, and in fact, Einstein's math was correct. He correctly solved the field theory equations to show that the universe was and is finite. When you take out his fudge factor, which he used to force it to be the answer he thought. And then at the Mount Wilson Observatory, Tom had visited there, I think, he actually got to look at the red shift, blue shift, right? Galaxies moving farther away or faster than others, observing the Doppler red shift, blue shift, actually confirming that the galaxy is expanding, meaning galaxies that are closer to us are moving away from us more slowly than ones that are farther away, indicating that the universe is expanding, that space is expanding, which means it can't be past eternal. It had to have had a beginning. And so Einstein's theory predicted this, even though he didn't believe his own math, of all things. So convinced, so astonished was a man named Eugene, Nobel Prize winning mathematical physicist Eugene Wigner, that in 1960, he actually wrote a paper on this, because so many interesting things had been discovered over the years. And he called the paper "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." Now, not a theist, not a Christian, I would say at best an agnostic. But even he had to acknowledge that, and these are his words, the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. And I actually have this paper. It's 11 pages long. It has no equations in it. It's just his or very few equations, but it has his observations about things that he's seen. And he's basically saying, we have no explanation for why math is so good at predicting practically everything that we throw at it. No matter what we look at, it seems to be able to predict reality with astonishing precision in almost every instance, in almost every circumstance. This put forward a really interesting period in history in the 20th century, where a bunch of really smart mathematicians and physicists got together and said, you know what? We've been thinking all along that science is the ultimate foundation of reality, but in fact, you know what? Math might actually be the ultimate foundation of all reality. Because math seems to predict these things, and then 50 years later, science confirms it. Maybe math is actually the ultimate explanation for everything. Maybe everything is reducible to mathematics. It's an interesting idea, actually, when you think about it. And so they set out to try to prove this. They set out to try to prove that math basically can explain everything, and that it's not science that's the ultimate foundation of reality, it's mathematics. And so, as they began their work, a young PhD student at the University of Vienna, a gentleman named Kurt Gödel, actually set out to prove this. And for his PhD, he was pursuing what he called a completeness theorem. That was his starting goal. He wanted to prove mathematically that math is complete in its description of all of reality. The most astonishing thing happened when he finished his work. He actually wound up proving the exact opposite. His math actually proved that math is incomplete, that math cannot describe everything, that math is not the sum total of all explanations of reality. Now, this was kind of a shock wave because a lot of people were starting to think, hey, math can do anything. Math can prove anything. And his math actually proved the opposite, that there are certain propositions which by definition can never be proven mathematically, that have to just be assumed to be true. And it was actually called his incompleteness theorem, Gödel's incompleteness theorem. We're coming up on the 100th year anniversary of this. It has never been disproven. And I'm telling you, people have tried because nobody liked this answer. Nobody liked this answer because everybody was convinced math was the ultimate foundation of all reality. And his math actually proved that it wasn't, that there has to be something else that can explain math, because math can't explain itself. Now, how did Gödel do this? It's actually very interesting how he did this. He set up, and if you ever get a chance to read, there's several good books on this, and his paper even uses this analogy. He set up what's known as the liar's paradox. Has anybody ever heard of the liar's paradox? Anybody? Okay. He said, and he used this example in his paper, he said, consider the following proposition. I am lying. Right now, this statement, I am lying. What are the two possible outcomes of that statement?
True or false?
Correct. If it's true, if I say I am lying and it's true, then what conclusion do you reach? I'm not lying, because what I said is true. What if I say I am lying and it's false? What conclusion do you reach? That the statement I am lying is actually true, because I am lying. So I'm not lying. I'm telling you the truth. I'm lying. That's a true statement. So you get into this paradox where if it's true, it's false. And if it's false, it's true. I want to let that sink in for a minute. What are your thoughts on that? The liar's paradox. I am lying. If it's true I'm lying, then I'm not lying. So the statement I'm lying is false. But if it's false, then the statement is true. So how do you resolve this conundrum, this paradox? Well, this is what Gödel used for his analogy for his incompleteness theorem. He basically said, and that's how my brain looks when I think about this, the statement, I am lying, cannot prove itself. Because if it's true, it's false, and if it's false, it's true. You don't know what the answer is. The statement cannot prove itself, which means there has to be some external point of reference outside the statement that we need in order to figure out if the statement is true or false. Because the statement can't prove or disprove itself. It's a paradox. So Gödel used this exact analogy and formulated his what is now known to be his incompleteness theorem. And I'll kind of go through this quickly, but again, I promise no equations, but I want to just show you his argument. He said any effective generated theory, and in this case, he's using mathematical theories, capable of expressing elementary mathematics cannot be both consistent and complete. And he goes on to define, for any consistent, effectively generated theory that proves certain mathematical truths, there is a statement that is true but not provable in theory. There are certain mathematical statements that cannot prove themselves. They need an external point of reference in order to determine if you can prove it or not. They are not self-proving, which again goes to Gödel's argument that math cannot explain itself. Now, this is not true for all mathematical statements. There are some which can, but there are certain ones which cannot prove themselves. And he actually gives some examples about an effectively generated theory cannot be both consistent and complete. If it's consistent, it's missing something because it needs an external point of reference, so it's not complete. But if it's complete, the mathematics shows it's not consistent. It cannot be both consistent and complete at the same time, meaning there's something missing from the formulation. And so, this is what Gödel used when he tried to look at this argument inductively. Now, I'm going to give an example of inductive reasoning here. This is how Gödel thought about it from an inductive standpoint. So, inductive reasoning is a little different than deductive. It starts with a claim, like in this case, most U.S. presidents have been over 40, and then it reasons to a conclusion that therefore it's likely that the next president will be over the age of 40. Now, with an inductive argument, is the conclusion 100% certain? Is it 100% certain that since most presidents have been over the age of 40, that likely the next one will be over the age of 40? Is it certain? Is that conclusion certain? No, because you could have a president who's under the age of 40. Now, it's not likely, we haven't had one yet, but it could happen. So inductive arguments can never deal in absolute certainty. They deal in likelihood of being true, right? Not certainty. They deal in probability or likelihood of being true. So Gödel used this exact idea for his incompleteness theorem. And I'm going to give an example. He said anything that you can draw a circle around cannot explain itself without referring to something outside the circle. So for example, if we looked at the water bottle and we said it, and we drew a circle around it and we said in its totality, this water bottle, can this water bottle explain itself? We would say no. So necessarily there has to be something outside the circle that points to what created this thing inside the circle. The information inside the circle, the bottle, cannot be both consistent and complete. It can be consistent, but it's not complete because it doesn't explain where it came from. Because there's something must be outside the circle that caused what's inside the circle. Systems of logic always rely on at least one true but unprovable assumption, again, which is outside the circle. And there are always at least one more thing than you can actually prove. There's always at least one more thing than is actually provable. And he actually concluded that a grand theory of everything is mathematically, logically impossible, which made a lot of people upset because they were working on the grand unified theory of everything, and his math showed that's not actually possible. Because there has to be something that describes math itself, because math can't prove itself. And if you're using math to try to come up with this grand theory of everything, you have to prove math is correct. And math can't prove itself. And these conclusions that he showed don't apply to just math and science. They apply to anything governed by the laws of logic. Anything governed by the laws of logic. So this is this is sort of my interpretation of how Gödel tried to describe this. So if I were to say, here's an iPhone, right? Here's an iPhone. Oh, I left it on the table. Here's an iPhone. And I drew a circle around my iPhone. And I said, can my iPhone explain itself? What do you think? Probably not. Yes.
The microphone fell off you.
Oh no! Oh, hold on. Oh, sorry. Oh, it's okay. That must have been a loud crashing sound. All right, let's see. Sorry about that recording, folks. Okay, is that better?
Sorry for interrupting.
Sorry. Can you see it? Can you hear it rather? Yeah. Okay. So.
Appreciate you.
Yeah. So we draw a circle around the iPhone. It cannot prove itself. What does that imply? That there's something outside the circle that explains the iPhone, right? Because the iPhone can't explain itself. What's in the circle is consistent but not complete because it can't explain itself. So what explains an iPhone? How about an iPhone making machine? Again, this is just me making stuff up here. But somewhere in China or somewhere around the world, there's a machine that makes iPhones. Right? That would explain where the iPhone came from. The iPhone cannot explain itself. It needs something outside the circle to explain it. And that would be the iPhone, in this case, the iPhone machine is explaining the iPhone. We draw a circle around the iPhone machine and we ask the same question. Does the iPhone machine explain itself? Can the iPhone machine explain itself? No. So what does that imply? That there's another circle outside the iPhone machine. Again, I called it an iPhone factory, right? But you keep building circles and you keep asking the question, what caused this? What explains this? Now, if I had more room on the screen, I could draw another circle and say, what explains the iPhone factory? Because iPhone factories don't explain themselves, as far as I know. And so you just keep drawing circles, bigger and bigger circles, and asking the question, what explains that? What explains what's in that circle? And you get your explanation, and you're like, cool. Okay, what explains that? Something else. Great, draw a circle around it. Okay, what explains that? Something else. Great, draw another circle around it. And you keep drawing circles and asking the question, what explains what's in the circle? What's going to happen eventually when you do this?
Infinite circles.
Well, yes.
You get to like the creator.
Well, could it be an infinite circle?
Well, that's what I was going to say. That if like you can't go back an infinite number of causes and get like a.
Okay. So what if I was a real maniac and I said, I want to draw the biggest possible circle anyone has ever seen in the history of reality. I want to draw a circle around the entire known physical universe. All stars, all planets, all galaxies, all suns, all moons, all everything, all of physical reality. Big circle. And I ask the question, does that explain itself? Now, in the past, people would say yes. People say, yep, universe, it's always been there, always existed, eternal, self-existent, always been here, no explanation needed. It's just always been here. But the science is now saying something quite different. The science is saying, no, actually, universe came into existence at some time in the past. And if it came into existence, something must be outside the circle that caused it. Because you can't go on forever. You cannot have an infinite series of circles. So, what would the attributes of this thing be that is outside this circle? What attributes would it have? What characteristics would it have? Well, it would seem to me that it must be true but unprovable. Something that has to be true but can't necessarily be proven, at least not with an inductive argument. With this inductive argument, it can't be proven. And that's one of Gödel's postulates, one of his incompleteness theorem postulates. So it has to be true but unprovable. necessary and uncaused. Why does the thing outside of this have to be necessary and uncaused?
So then you'd be making another circle.
Correct. Everything in the circle is not necessary. It's not contingent. It doesn't have to be here. It does not exist necessarily because it came into existence, which means it didn't have to be here. And whatever's outside the circle itself cannot be caused by something. Otherwise, we draw a circle around that and keep asking the questions. Yes, go ahead. I think you were first.
Why is it that the circle has to stop outside the universe and we can't put another circle around God or a creator?
You could, but then what would the next logical question be?
Where does that?
Where did
the aliens come?
What created God? Right? What created God? What do you think? I'm sure you've gotten that question from unbelievers. Where did God come from? What created God? How would you answer that?
He's eternal.
Okay. For centuries, scientists thought this was eternal, and everybody was okay with that explanation, and self-existent. But now that they've discovered this is not eternal and self-existent, something else must be eternal and self-existent. Maybe it's a creator. So I don't know why you would accept this being self-existent and eternal, but not at least consider the possibility that a creator could be self-existent and eternal and uncaused. Since we know this is no longer self-existent and eternal. We know this came into existence. Yeah.
I was going to say, well, God works on a different plane of, because like if we're insinuating that there is a God, then that means that, and we also say like the laws of thermodynamics,
Yep.
like matter can create matter.
Yep.
So that means we're working on a different plane in order for something to create matter. And
Yes.
therefore we can't
Right.
apply.
Right. Somebody one time said, you'll never have a physical explanation of physical existence. In other words, matter can't create itself. Physical cannot create physical out of nothing. It can only create it out of already existing physical. But then the question is, where'd that come from? Where did that physical stuff come from? This would seem to imply that it had to come from something outside the circle that itself was not physical, but caused physical reality to come into existence. I would say it has to be infinite. This is what's outside the circle, has to be infinite and eternal. Why does it have to be infinite and eternal?
If it wasn't infinite, you could draw a circle around.
You could, because everything in here is finite and temporal, which means everything outside the circle logically must not be finite, infinite, and not temporal, eternal, because that excludes everything that's infinite and eternal, because everything that's in here is finite and temporal. So whatever is outside it has to be infinite and eternal. Otherwise, yes, you could draw a circle around whatever that thing is, because it's not infinite and eternal. It's finite. It's not necessary. It's caused, right? So yes, whatever's out here can't have been created by something. It has to just exist. And it has to be eternal. It can't ever have come into existence, because every physical thing that's come into existence is in the circle. So whatever's not in the circle has to be not have come into existence. It has to be eternal and infinite. This is a tough one. Why does it have to be singular and not a group? Why does whatever that thing is have to be singular and not a group?
Is it because of the circles? If you made one more circle, if there was multiple circles, then it would overlap and it wouldn't explain it. You would still need a circle to
Correct. You would still need a circle around all of that. You would need, whatever this thing is outside the biggest circle I could have ever created, it has to be one thing. It has to be of one substance. Because if it's composed of parts, then it's created. It's not eternal. And if it's composed of parts, it sure as heck isn't infinite, because parts are finite. So whatever it is, it has to be one thing, whatever that one thing is. It cannot be made of parts. It can, because otherwise it would be finite and temporal. This is a tough one. Why does it have to be immaterial, whatever's outside the circle? Why does it have to be non-physical, non-material?
Because since the universe is material and it has to be explained how it started, what had made it can't be of the same.
Correct. You can't have at least we have no evidence of a self-creating universe. And logically, that would be a problem, right? Logically, something creating itself causes some pretty serious logical problems, because then it has to exist and not exist at the same time and in the same way, which is a real problem logically. So whatever's out here can't be physical. It has to be immaterial, because all of physical material reality is in the circle. So everything outside the circle cannot be physical. It cannot be material. It has to be immaterial, non-physical, that created the physical material. I would argue, given what we know about the universe, it's whatever that thing is has got to be pretty darn powerful. And I would argue, volitional and rational, intelligent. I mean, we see order and structure in the universe. We see mathematics, abstract mathematics, predicting physical reality with astonishing precision. Clearly, this is not a happy coincidence. There seems to be some intelligence behind the scenes here. And again, I would say rational and volitional as well. Again, you can reach your own conclusions. I'm not trying to force an answer on you, but I'm thinking when I see true but unprovable, necessary, uncaused, infinite, eternal, singular, immaterial, non-physical, powerful, intelligent, rational, volitional, I'm thinking that's kind of sounds like what people have been calling God for centuries, if not millennia. An all-powerful, non-material, self-existent, necessary, uncaused agent outside of the physical world. And logically, this holds. Logically, this holds. Because if it doesn't hold, then, like somebody said, you got to draw another circle around that thing outside the universe. So, what are the implications? Let's just kind of think through the implications for a minute. Some of the implications are really interesting to look at. Belief in an unprovable creator who is outside of time, space, and material is actually not illogical. It's actually very logical. Now, we can argue over what this uncaused, timeless, spaceless, immaterial creator is. I mean, if you've got evidence that the flying spaghetti monster is the uncreated, outside of time, space, and material entity that I'm more than willing to listen to you if you got good evidence for that. But whatever this thing is, logically, it has to be there. Something has to be there. The math requires it. Logic requires it. So to construct a necessary and consistent logical model, I would argue God or some type of creative agent is not just reasonable, but it's actually necessary, because the circles can't go on forever, as you pointed out a moment ago. There has to be something that is the final circle to which everything else points. This is why the existence of God actually seems intuitive to a lot of people, even though they may not really be able to quantify it. I don't know if you've ever had this experience. Anybody ever gone like on a foreign mission trip, like to a really remote area of the world that is unreached, and you start talking to them about the existence of God? What kind of response do you get? The response I've seen is, oh, yes. We kind of knew there was something that explains all of this, but we just didn't know what it was. So we've been over here worshiping this rock. But that actually kind of makes sense. There has to be something that explains all of this. And that's the intuitive aspect of this. So it can't be strictly proven inductively. It cannot. But there does seem to be this sort of innate intuition that something has to explain this. And I think it's because humans are rational, logical beings, and they can think through the logical steps. And so they then think, okay, there's got to be something that explains all of this. This is the one that gets people very upset. So I say this very delicately to my friends in the scientific naturalist worldview, of which I used to be one. But it pretty much puts the bullet in the head of scientific naturalism, which says that matter has always existed and is self-existent and eternal and can explain everything. Matter and science cannot explain everything because there's got to be something outside that last circle. Nature and matter cannot explain itself. There can't be more matter outside the last circle, because then you just draw a big circle around that and keep asking the next question, right? So it's actually a very tough obstacle for folks with a scientific naturalist worldview. This one really gets people upset. I would argue if God is the explanation for this, then that kind of also gives atheism a real problem. Because now they're going to have to postulate something that violates the laws of mathematics and logic, because something is out there beyond that last circle. Logically, math requires it. And so that's a very difficult position, because now you're having to explain something that can't be explained, that can't even be conceived. And look, this is not unusual. All fields of study, science, math, philosophy, everything relies on unprovable truths. Like, for example, I said in the beginning, we got deductive arguments and inductive arguments, right? Logic. Can anybody prove to me that logic is valid? How do you prove logic is valid? Can logic prove itself?
No.
It can't. You just have to look at it. It's a self-evident truth. It's like this. It's like this. I know you know this one. Shortest distance between 2 points. What is it? Okay. Prove it. Prove it. Prove it. Otherwise, I won't accept it. Show me. Prove it. Somebody come up here and prove it. You cannot.
You use a ruler and measure the distance with the ruler, but it's still based on, if I put 3 markers up there and measure the distance, it's still based on the distance of the markers.
Yeah.
So you have to prove, how do you know the distance?
Correct. It relies on an unprovable assumption. Everything relies on unprovable truths. Now, I would argue you can just look at it and go, yeah, shortest distance between 2 points is a straight line. But I can't prove it. It's what's known as a self-evident truth. It proves itself. It is its own proof. There are mathematical postulates that are like this that can't be proven. You can't prove it with anything outside of itself. And that is true for all fields of study. Logic, that is the foundation of philosophy, can't be proven. It just has to be assumed to be correct. Now, you could test it over and over and over and over and over again, but maybe the next time you do it, it won't work, because you can't test it infinitely. You just have to assume it's correct. It's fundamental first principle truths cannot be proven. They have to just be accepted or rejected. Prima facie, face value. And so all fields of study have this. All fields of study have this. Logic, inductive reasoning, and deductive reasoning are the foundations of science and math. But those things cannot be proven, which means science and math cannot be absolutely proven, because the logic which is used, the deductive and inductive logic, which is the basis of these things, can't prove itself. You just have to accept that, yep, okay, I believe. You have to push the I believe button. Yeah, I believe deductive reasoning is valid. I believe inductive reasoning is valid, but I can't prove it. All fields of study rely on unprovable truths that just have to be accepted. Well, this is the same thing. This is the exact same thing right here. Can't prove it, but there has to be something that would explain what's out there. So, conclusions. There appears to be an inexplicable correspondence between math, abstract math, and physical concrete reality. And I've only given you just a few examples, but there are many, many, many. And if you want to read Wigner's paper, he does a good job explaining a lot of them. The correspondence appears at every level of the natural world. We have yet to find a part of nature where math does not describe what's going on. That's pretty astonishing, actually, quite frankly. There is not one aspect of physical reality that math cannot describe. That's interesting. The correspondence does not appear to exist necessarily. In other words, there's no reason to think it has to be this way, but it is. There's no evidence that would suggest it must be this way, but yet it is time and time and time again. What are the odds? It's just a happy coincidence? You decide. I would argue the evidence certainly seems to imply some type of intelligent agent that ordered the world in such a way and created the ideas of mathematics that describe the physical world that we live in. If God really did create physical reality, then God would also create the mathematics that describes that exact same physical reality, which kind of indicates maybe why the correspondence is astonishing. There's not one place where the math doesn't correspond to physical reality. So math clearly is not a human construct. Now, we understand it with our minds, but it is outside of us. It was here long before any of us were here, and it'll be long after we're gone. God's existence, I would argue, can be logically inferred, both deductively and inductively. Again, I'll leave that up to you. You decide if the arguments were reasonable. And shockingly, or maybe not shockingly, I'm not the first person to reach this conclusion. People have been reaching this conclusion for centuries, that there does just seem to be something that explains the ultimate metaphysical basis explanation for everything that we see. Because we know now that it doesn't have to be this way. It doesn't have to exist, but yet it does. And Galileo saw it too. They absolutely saw it. And they recognized it for what it is. And these were guys who didn't have calculators and supercomputers. They had slide rules and pencil and paper at best, maybe even a ruler. But they understood the correspondence between abstract mathematics and physical reality. And they wrote about it. They saw it. So I leave it up to you. You decide. If you think it's just a happy coincidence, that's fine. We can talk about it. But if you think there might be something there, we can talk about that too. So any questions or I don't know how long I went. Ooh, I kind of went a little long, actually. Oh, no, not too bad. 8:20. Okay. Questions? Comments? Yes?
I just have a question. So we talked about the circles and everything, and how math cannot prove math, and logic can't prove logic.
Correct.
How does the Bible, from the Christian theist viewpoint,
Right.
how does the Bible fit into all that?
So again, as I said in the beginning, this is not an argument for the validity of Christianity or the reliability of Scripture. So that, if you wanted to go down that road of proof, you'd have to look at the historical evidences for Scripture and the Bible. You'd have to look at the historicity, the accounts of the New Testament and Old Testament, in order to establish the validity of those documents. So yeah, this is completely separate from historical proofs. There's no history here at all. So it's completely separate. So again, this is just the existence of a creator that logically must exist. Something must exist that creates everything that doesn't need to exist but does exist. Yes?
The way I saw it was like, so if you start with biology, chemistry explains why biology is the way it is.
Okay.
And physics explains why chemistry is the way it is.
Sure.
Math explains
why physics the way it is.
How do we know that by saying God explains why math is the way it is, isn't a God of the gaps? Like, how do we know there's not something else behind math in the sequence?
There could be. There absolutely could be. Because in other words, you're drawing a circle around God and saying what created God, right? So again, that would be a very valid way of looking at it. But the problem with that is now you have to come up with an explanation for that created thing. And you can't go on drawing circles forever. Ultimately, there has to be a last circle, right? So, and plus I would argue too that just because something, how do I say this? When we look at the inference to the best explanation, it doesn't have to be able to explain everything, only the thing that we're looking at, right? In this case, we're just looking at math, right? And so if we hold the idea that math is abstract, not physical, then it would seem like, and if you hold the view that math is not a human creation, that it existed before we got here, that 2 + 2 = 4 long before any humans walked on the earth, math is not a human creation, then it would have to come from something or someone, some entity of some kind. But yeah, no, you can certainly draw a circle around God if you want. You certainly could. But then you got to answer the next question. Yeah.
How could you shorten what you were talking about into something that you would say to someone if you're trying to kind of defend the idea of God?
Yeah, it's a good question, because obviously you're not going to go through this 90-minute presentation with somebody, on Chancellor's Walk. That's probably not going to work too well. So I think you can just ask simple questions. Like if you find somebody who's a scientist or a mathematician, which I love to talk to, ask them, hey, I've noticed that math is really amazing. Like it seems to be able to predict everything in the physical world. How do you explain that? Like where did that come from? Why does it work the way it does? Because humans aren't capable of creating something that can do that. Like, where does that come from? Or science, like we perform a chemistry experiment and we combine sodium and chlorine and we always get salt. We never get plutonium. Like, why does it work that way? Why does it always work so consistently and regularly and repeatable and ordered and structured? Why are the planets always in fixed orbits in motion? Why does the wave function describe waves at the beach perfectly? If you find a surfer, that's a good one to ask. Ask a surfer that one, right? Right? And see what they say. Ask them what they think. Look, it's a fair question, right? I've noticed something. I've noticed that math seems to be able to predict everything. Where'd that come from? How does that work? I don't know anything about math. Can you explain this to me? See what they say. Be interesting to hear what their answer is. Right? It'd be interesting to hear. Is it a gigantic, unbelievable coincidence? Yeah, okay, maybe. But seems very, very unlikely based on what we've observed in the natural world. So yeah, you can just use it as formulated as questions and just kind of tease out some discussion maybe to see what they think. I think it's good. Yeah, Christian.
How would you prove that math isn't just a thing in our head, or basically just nominalism? Like, you come up with a coherent system.
Yeah.
How do we know a system's not artificial? We're just projecting it.
So I would say the correspondence between math and the physical reality is a good pointer to that. Because to me, if math was just a creation of our minds, then prior to humans deriving the wave equation, waves wouldn't behave the way they do, right? They would behave some other way. But yet there seems to be this correspondence between the two that's very precise. So we would argue that, again, depending on your if you have a nominalist that you're talking to who says, well, logic is just a human construct, right? Ask them to prove it. How is logic a human construct? Because I don't see any way logic can be proven or prove itself. Yeah.
Saying this that math and logic, these are naturally discoverable from nature.
Yes.
Okay, so so where you would say nominalism would be once we come up with theory for waves,
sure,
that's when waves decide to start acting like waves, but before that, they wouldn't have done it.
Yeah. So before Newton had his theory of gravitation, everything was just floating around in space with no gravity. But gravity, everything goes down to the earth. Well, no, we know that's not true, right? Gravity was always there. Newton was smart enough to come along and say, wait a minute, gravity. Ooh, acceleration, mass, velocity. Hey, let me try to solve this. Look, an equation that describes this. But gravity was always there. Math was always there. He just discovered that it was there. The math. was there. Does that make sense? I would argue he didn't create calculus. He discovered calculus. Calculus was always there. Nobody knew it. And actually, little historical interesting point, Newton in England, Leibniz in Germany, discovered, or if you will, if you think they created it, created calculus almost at the exact same time on two different continents, although they never talked to each other, yet they came up with the exact same formulation for calculus. Seems like a pretty insane coincidence to me. That would be like somebody painting a Mona Lisa in France and somebody painting the exact same Mona Lisa in Japan at the same time for the first time. I mean, what are the odds you're going to get that? Seems pretty unlikely, right? So to me, that kind of points to the fact that something like calculus or mathematics isn't created, it's discovered. And two extremely brilliant men discovered it more or less at about the same time. Totally separate countries, totally separate worlds, totally separate languages. They didn't even speak the same language. And yet they both discovered the same thing within a few years of each other.
So I think my quibble might be just that if we're trying to essentially argue for God's evidence, God's existence based off natural laws and logic works this way, right? If logic didn't work this way, we would never be the wiser at all. We wouldn't be thinking here at all. So I feel like that's almost kind of a presupposition for the argument. Like this has to be this way anyways, because it is this way, right? So anything added on to that, so it's not like it proves a specific point sort of thing. I think it's more of an argument against pure material randomness.
Okay.
Right? It proves that there's got to be more than just atoms. There's natural laws, but it doesn't necessarily prove that there is a super intelligent, powerful, almost personal creator that's almost interacting with.
Right, and I didn't put personal on there because, again, we're just talking about a creator God. So yeah, if you want to go down the route of a personal creator, that would be some other line of evidence, like, the Bible or some other historical book. But I would say that, back to your original point, if logic didn't exist, would we even be here? Would the universe, that means the planets and the solar system would be completely irrational. Not sure how human life would have evolved or created because, as far as I can tell, natural processes are pretty repeatable and regular and ordered. But now all bets are off. We got no logic. Anything goes. Seems like that would be just complete chaos. And I don't know how you get any order in anything out of a world like that. I'm not even sure we'd be here to question it. I'm not even sure we'd be here to ask the question, quite honestly. So, it's interesting to think about. It's interesting to think about for sure. But there are just some things that we have to just take as a presupposition, as an assumption, because we can't prove them otherwise. We can't explain them outside of themselves. But no, it's good question, good point. But again, it's at least worth considering, I would argue. It's at least something worth considering. So, okay, good. Any other questions? Or, in the back.
So it's an argument that math and logic is also applicable. Can't prove itself because of what you explained.
Yep.
It's a logical argument proving that.
Correct.
So it's this argument for circular reasoning because it can't prove itself either. So
Correct.
we have to assume logic just works, which is what the argument says.
Correct. It goes right back to this. All fields of study, including logic and math, rely on unprovable truths. If you deny that logic is valid, which you can do, how far do you get? You get nowhere, because everything is presupposed on those ideas. It's like, in other words, you have to use logic to prove logic is invalid. Huh? Right? It defeats itself. So that's why these are unprovable truths. You either accept it or you reject it. You say, nope, I don't accept that logic is valid. What's my next question to you? How did you reach that conclusion? Because it kind of sounds like you needed to use logic to reach that conclusion, but you just got done telling me logic's not valid. So how'd you reach that conclusion? No answer. Yes.
So, how is self-evidence not a proof?
It is a proof. It's just not a formal proof. So in other words, it's a self-evident proof. So again, the shortest distance between 2 points is a straight line. That's a proof. It's just, it can't be proven outside of itself. It can only prove itself, right? It can't prove itself. It has to be something that is self-evidently true. And that principle is the basis of all, Euclidean geometry, right? If it's not true, then all of Euclidean geometry blows up.
But I'm saying, isn't it like something being self-evident? Isn't that enough? Like, why does it need an explanation outside of itself?
It doesn't. It doesn't. It just proves itself, right? There are certain things that are just self-evidently true that are their own proof and need no further proof. But you either accept them or you reject it, because you can't prove it strictly true or false. It's just self-evident. You have to either accept it or you reject it, right? But that's the nature of truth anyway, right? Truth is that way. You either accept it or you don't.
What do you mean by proof, saying that it proves itself, if you're also saying it's an unprovable truth? Are those incongruent?
No, it's unprovable outside of itself. It can't be proven external to itself. So it is its own proof, right? Like, for example, like the sum of the angles of a triangle is 180, right? And that's one of Euclid's postulates. How could you prove that exhaustively? You'd have to draw every single possible triangle and measure every single angle and show that the total is 180. Is there any way you can do that? Every triangle conceivable. I would argue you can't. You just can't. And so...
I think they're actually using for the triangle one.
Yeah, right.
I think it's a really long one, but that one has a truth.
Right.
I would stick with the straight line.
Okay, straight line. We'll go with the straight line. All right? Go with the straight line. How do you prove this other than... The only way to prove this is to do this. Is to say, nope, that's longer. Nope, that's longer. Nope, that's longer. And draw every one of those lines forever. Measure all of them and say, yep, they're all longer than that straight line. So it's self-evident. This is the shortest distance, right? So, but can I strictly prove it? No, I cannot.
You can.
No, I can't. I can't draw every line.
You don't have to.
Yes, you do.
No, you don't.
Strictly, you do.
No, you strictly don't.
Yes, you do.
Tautologically, the definition of a straight line between 2 points is the shortest distance. Is it possible to calculate the distance between 2 points in any fashion? Can you calculate distance?
You can.
So
what do you mean calculate?
If there are 2 points, then tautologically there is a distance between them. If you're on a 2D space,
Sure.
The tautological definition for the shortest distance is represented by a straight line.
And how do you know that?
You can do this in 2 ways. Well, mainly in one way. You take the straight line, and if your goal is to see, okay, is it possible to make the line shorter or longer? Well, the only way you do that is by manipulating it. And you can see that you have 2 options of manipulation. You can manipulate it in the positive or negative direction. You can't manipulate it in other directions. And you can tell in the 2 possible ways of motion that this line currently has that any movement in either of those directions increases the distance between the 2 points. So therefore, tautologically.
Right. So you have to test it. You have to do tests. You have to do samples.
No.
Yes, you just explained testing and sampling to me. You just explained you got to move it, you got to do this. So you're trying to prove it exhaustively.
Does a parabola extend to infinity?
Define infinity.
Man.
An
It's just so
actual
sad, man.
an actual infinity or an abstract infinity?
You can choose either of those if you'd like.
Well, I don't think an actual infinity exists. So I would say it's an abstract infinity.
How do you know that?
I don't. I can't prove it. I can't prove it. It's an unprovable proof. It's an unprovable truth.
The point is, tautologically, the definition of the thing you're describing is the shortest distance, and the representation of that is the straight line. So when you say, like, you can't prove it, that doesn't mean anything. The proof is in, like...
In the definition.
Not in the definition. Well, yeah, technically.
It's definitionally true. That's a self-evident truth.
But it doesn't define itself. It is defined, right?
By itself.
No, not by itself.
I would argue it is.
Okay.
I would argue it's defined by itself. What else defines it? Do I define it? Do you define it? I don't think so. It defines itself.
Can I ask, are things that are self-referential in this way, or self-proving,
yes,
is that a less valuable or equally valuable proof to something that is externally verified?
I would not say so. Again, that's maybe my opinion of it, but no, I would say not. I would say not, because many things that are provable with external data or external points of reference rely on the self-referentially provable things in order to be valid. So I would say no. No, I would say not. I'd be willing to accept a self-referential proof, self-defining proof versus one that's externally proven equally, as long as the logic is correct, right? As long as you've done the math correctly, I would say I would treat them as equal. Yeah. Yeah.
So can math not also be self-referential in the same way?
Yeah. Yeah, I mean, well, not. What do you mean self-referential?
Self-proving in the same way that something, if something that is self-proving,
yep,
is of equal. Are you okay? Do you?
No, I'm good. I just kind of spilled it. Sorry. That's okay. That's okay. But no, I think Gödel's theorem proves that math is not self-referentially provable. That's Gödel's theorem, that math is not self-referentially provable. But people thought for many years that it was. But yeah, his theorem, I think, proves that it's not. So, and I can give you the paper if you want to read it. It's pretty crazy, but it's an interesting proof. Yeah.
Gödel's paper proved that there has to be something like outside of the universe that proves math, but it's just proof that math's not necessarily the only way of. It's not that it can't possibly prove everything. You have to have other things.
Yeah, I think the second. Okay. Yeah, I think the latter. Yeah, I think the latter. And again, that came as a big shock to people in the 1930s and 40s because they thought math could prove everything, including itself. But it turns out it can't prove everything, including itself. Yeah.
Going back to Christian's question.
Yeah.
I don't know what is it basically
things are what we call them.
Math is based on some primitives, some axioms that we have to accept as true.
Correct.
That might not be easily provable.
Right.
Or not provable at all.
Correct.
And so his concern is, what if how do we know that the math is truly what is explaining everything based on unprovable axioms? What if there's an alternative, Fernari math, that might actually be explaining better? We just haven't discovered it yet.
I would say
is that kind of where you're getting with that, Mr. Ferrari?
It's an expert in Fernari math. My concern is that it seems that logic is not tautological. Actually, to be self-evident is different from being tautological.
I would agree.
And by tautology, which means it defining, it's like
right.
You know, when something defines itself.
Right. Right. A tautology meaning it doesn't have anything outside of itself. It's just.
It's true by definition.
Correct. Right. Like like this.
But that's not what logic is. Like logic doesn't define itself to be real. You just find it real. Like you just cannot get around it.
I would agree. That's the nature of a first principle truth.
So my question is that it seems like while math needs an explanation, it doesn't seem like logic needs a circle around it. Like it does explain itself. Because to draw the circles, you need logic, right? There can't be a circle and not a circle.
Right.
So you need the law of non-contradiction already to do the circle.
You have to assume the laws of logic are valid. A priori.
So that would mean the logic is outside the circle. It's like you can't put a circle around it.
Correct.
Because I guess that's my quote. It's like the sub-discipline of logic seems to be outside this whole.
I got to think about that. I see what you're saying. I got to think about that because there would seem to have to be an ultimate source of logic.
Yes, and that's what because since God makes the logos.
Okay.
Like, since logic flows from its nature, that would make sense. We would expect logic to be a circle independent question.
Okay, outside of the circle.
Yeah.
Okay. I think I could agree with that. Based on just kind of what you're saying. But I don't think it is. I think it's only descriptive. I don't think it's prescriptive. I don't think it's causing anything to happen. It's just describing what happens, I think.
And the way that math be different is you can't. Math isn't self-evident, right? It's discovered.
Right. Yeah, I would agree. I would agree. Okay, no, I mean, those are good questions. Yeah, I see what you're saying there. Okay. Anyway, just something to think about. I mean, just something to think about. If you're curious or you want to talk some more, let me know. I don't want to keep people too long.
Since we are running late, yeah. If you want to wrap us up and pray, unless anyone else.
Yeah, we can. Any other questions or comments? No? Okay, I'm going to go ahead and pray. We'll wrap it up, and then, I'll hang around if we want to just chat some more. I appreciate everybody being here tonight. Dear Lord, we thank you for today, and we thank you for the opportunity to meet and talk and discuss. And Lord, we thank you for all of the individuals that are here. Thank you for the great questions and the dialogue and the discussion. And Lord, we just pray that you will be with the students this semester as they're beginning their spring semester. We just pray for safety, and we pray for great opportunities to witness and interact with other students and faculty. We pray that everyone will be safe, that it'll be a productive semester. We pray for opportunities to share the gospel. We also pray, Father, that you would be moving in the midst of this campus, and Father, that we would be able to see and perceive what you're doing and take action and join you in your work. And we just thank you for all you've done for us. We pray you would be with us tonight, be with us this week, and we ask this in Christ's name. Amen.